Hello students, this is Nilanjana Sanyal from onlinemathtutor.me and ePodashana. Today we will be doing a problem on inverse variation. In our last session we had done a word problem on direct variation. Today we will be doing another word problem on inverse variation. But before moving on to the question, let us first of all clear our concepts regarding the direct variation and the inverse variation. What do we mean by a direct variation and what is an inverse variation? Okay, so let's start. Suppose the cost of one notebook be equal to INR 50 or 50 rupees. Therefore, the cost of 5 notebooks will be 5 times 50, that is INR 250 or 250 rupees. And what will be the cost of 10 notebooks? Ten times 50, that is INR 500. Instead of INR, you can take dollar or you can take any other currency as well. So you see over here, as we increase the number of notebooks, the corresponding price increases. If we want to buy 5 notebooks, we have to pay 250 rupees or INR 250. But if we purchase 10 notebooks, then we have to pay a price of INR 500. So we see there are 2 parameters. The first one is the number of notebooks and the second one is the price, corresponding price. As the number of notebooks that we purchase increases, the corresponding price that we have to pay increases as well. So as the first parameter increases, the second parameter also increases proportionally. If the first parameter decreases, like the cost of 10 notebooks is INR 500. Now, if we think of purchasing 5 notebooks instead of 10 notebooks, we have to pay INR 250 instead of INR 500. So, as the number of notebooks decreases, the price that we have to pay decreases correspondingly. So, as one of the 2 parameters increases or decreases, the other parameter also increases or decreases proportionally. This is a case of direct variation. The first parameter is directly proportional to the second parameter. Over here, the number of notebooks varies directly as the cost. Number of notebooks varies directly as the price or is directly proportional to the price. Now let us take up another example. This is a case of direct variation. Now let us take up an example which is a case of inverse variation. Let there be 100 chocolates. And let there be 10 children. Then if we want to distribute these 100 chocolates among these 10 children, each child will be getting 10 chocolates. So each child gets 10 chocolates. Now imagine instead of 10 children, there are 20 children. And we want to distribute these 100 chocolates among these 20 children. Now each child will be getting 5 chocolates. Even in this case, we are having two parameters. First is the number of children, and the second is the number of chocolates that each child gets. In this case, we see as we are increasing the number of children, the number of chocolates that each child gets decreases. When one of the two parameters increases, the other one decreases proportionally. If the first one increases, the second one will decrease, and vice versa. So this is a case of inverse variation. One is increasing, other is decreasing. This is denoted by number of children is inversely proportional to number of chocolates received by each child. This is a case of inverse variation. And this is denoted by 1 by this thing. Number of children is inversely proportional to the number of chocolates received by each child. If number of children increases, number of chocolates received by each child will decrease. And if number of children decreases, number of chocolates received by each child will increase. If one of the two parameters increases, the other one will decrease, and vice versa. This is a case of inverse variation. So let's start with the sum. Now this is the question. The volume V of a given mass of gas varies inversely as the pressure P. This is nothing but the Boyle's law, which states that at a constant temperature, the volume V of a given mass of ideal gas varies inversely as the pressure, or volume V of a given mass of gas is inversely proportional to its pressure. Varies inversely and is inversely proportional to mean the same. Now, when V or the volume is equal to 2 meter cube, the pressure is equal to 500 Newton per meter square. Find the volume when the pressure is 400 Newtons per meter square, and find the pressure when the volume is 5 meter cube. So let's start answering. Over here they are saying that volume V is inversely proportional to P, or varies inversely as the pressure P. So we can write this as V. This can be changed to an equation by adding the constant of proportionality. So this can be written as K times 1 by P, where K is the constant of proportionality. You can take any other alphabet as well. Now there are two questions. One is find the volume when the pressure value is given, and the second one is we have to find the pressure when the volume is given. But first of all, in order to find these, we have to find the value of K. For that, we will be using this information. The volume is 2 meter cube when the pressure is 500 newtons per meter square. So we put these values in this equation to get the value of K. 2 meter cube is the volume, and K times 1 by 500 Newton per meter square. This is the pressure. Therefore, the value of K is, we take this 500 to this side, so it becomes 2 meter cube times 500 Newton per meter square. And 2 times 500 gives us the numerical value of 1000. And over here we are having meter cube in the numerator and this meter square in the denominator, so it will be Newton meter. So the value of K is 1000 Newton meter. Now that we have found the value of K, we are in a position to answer these two questions. Find the volume when the pressure is 400 newtons per meter square. So again, we are writing this equation. V is equal to K times 1 by P. And in place of P, we will be putting the value, and of course for K, we have to find the value of V. In place of K, we write 1000 Newton meter, and in place of P, we write 400 Newton per meter square. These two can get cancelled, and over here it is meter, and this is meter square in the denominator, so it will be going up, but these two will get cancelled. So we have 5 by 2 meter cube or 2.5 meter cube. This is our first answer, the answer to our first question. And coming to the second question, now we have to find the pressure. So again we write the equation, that is V equal to K times 1 by P. And in place of V, we write 5 meter cube. In place of K, we will be writing 1000 Newton meter. And this P will be kept as it is. So this becomes P equal to 1000 Newton meter by 5 meter cube, and this is 200 Newton per meter square. The corresponding pressure is 200 Newton per meter square. So we have got the answers to both the questions. Now it is the time to write the answer, the final answer, in sentence format. Answer. Even though it is not given as A and B in A and B form, we are writing the answer in that manner. This is the answer to the first part. The volume is 2.5 meters meter cube, sorry, when the pressure is 400 Newton per meter square. And the second one is the pressure is 200 Newton per meter square when the volume is 5 meter cube. So we have answered the two questions and we have known how to solve the word problems related to inverse variation. So students, this brings us to the end of this session. Thank you for listening.